Hello, and welcome to the next lesson in this free Hyper-V training course for Windows Server 2012 and Windows Server 2012 R2. In the last lesson of the course, I introduced you to Guest Integration Services and showed you how to install and upgrade these services on a virtual machine. If you have not yet seen our last lesson, then I strongly recommend that you do, as it contains useful theory and prerequisites to this lesson. In this lesson, I will focus on the Hyper-V services that make up the Guest Integration Services package. I will start by looking at how Guest Integration Services are enabled and disabled for virtual machines. After this, I will look at the actual Hyper-V services and will demonstrate how they work. Before we get started, let's just take a moment to remind ourselves exactly what Guest Integration Services are. Guest Integration Services, in a nutshell, is an add-on package which can be installed onto Hyper-V virtual machines. That is, after you have created a Hyper-V virtual machine and installed your guest operating system, you can then, optionally, install Guest Integration Services. When Guest Integration Services are installed, new functionality is added to the virtual machine. These new features ultimately make the virtual machine much easier to manage and administer. Starting with Windows 7 and Windows Server 2008, Microsoft has started to include Guest Integration Services with their Windows operating systems. This essentially means that when you install Windows 7, Windows Server 2008, or a newer version of Windows onto a virtual machine, Guest Integration Services is installed along with it. Over the years, Guest Integration Services have been expanded and improved. At the time of this recording, the latest release of Guest Integration Services is version 6.3, which is built into Windows 8.1 and Windows Server 2012 R2, Microsoft's latest operating systems. Earlier versions of Windows, such as Windows 7, Windows Server 2008, and Windows Server 2008 R2 all ship with previous releases of Guest Integration Services. However, these can be upgraded to the version of Guest Integration Services included with your Hyper-V host. Much older operating systems, however, such as Windows XP, Windows Vista, and Windows Server 2003, come with no Guest Integration Services built in whatsoever. If you wish to use Guest Integration Services on any of these operating systems, you will have to install them from scratch. As you may recall from the last lesson, Windows Server 2012 Hyper-V hosts ship with version 6.2 of Guest Integration Services. This release of Guest Integration Services will install the following services onto virtual machines: the Hyper-V Data Exchange Service, the Hyper-V Guest Shutdown Service, the Hyper-V Heartbeat Service, the Hyper-V Remote Desktop Virtualization Service, the Hyper-V Time Synchronization Service, and the Hyper-V Volume Shadow Copy Requester. With the release of Windows Server 2012 R2, Microsoft released version 6.3 of Guest Integration Services. The main difference between the two versions is that version 6.3 added an additional service called the Hyper-V Guest Service Interface, which is unavailable to virtual machines running on a Windows Server 2012 Hyper-V host. Later on in this lesson, I will discuss these services in a lot of detail and will demonstrate how they work. Before we do this though, it pays to understand how Guest Integration Services can be enabled and disabled. The majority of Guest Integration Services are enabled by default. That is, after you have installed the services onto a virtual machine, you are able to use most of them immediately. When guest integration services are installed onto a virtual machine, a set of new services are added to the guest system. Although it is possible to start, stop, pause and resume these services from within the virtual machine itself, it is ultimately the Hyper-V host that determines which of these services the virtual machines are permitted to use. To demonstrate this better, I will now change over to my Windows Server 2012 R2 Hyper-V host to show you how to enable and disable guest integration services for a virtual machine. From the desktop of your Hyper-V host, first, open Server Manager from the bottom left corner and select Tools from the top right corner. From the drop-down list, select Hyper-V Manager. This will open the Hyper-V Manager console. From the list of virtual machines, you can see that I have 3 guest systems running: vServer 1, vServer 2, and vServer 3. In the last lesson, I installed guest integration services onto all 3 of these virtual machines. However, although the services are installed, I do not have to use them. That is, it is possible to enable and disable the integration services for every virtual machine at will. To do this, right-click on the virtual machine and select Settings from the drop-down list. This opens the settings for the virtual machine. From the Management section at the bottom, select Integration Services. In the main pane, you can see which guest integration services are permitted to run on this virtual machine. When an integration service checkbox is ticked, it is enabled, and the virtual machine is able to use it. However, if the checkbox is cleared, the integration service is disabled and cannot be used by the guest system. By default, the operating system shutdown, time synchronization, data exchange, heartbeat, and backup volume checkpoint services are all enabled by default. Guest services, however, which is only available on Windows Server 2012 R2 Hyper-V hosts, is the only service which is disabled by default. Enabling and disabling integration services is simply a matter of ticking and unticking the relevant checkbox. However, you can also perform this task using Windows PowerShell. To do this, first, open a Windows PowerShell prompt. To enable an integration service, you can use the Enable-VMIntegrationService commandlet. Next, I will add the VM name switch, followed by the name of the virtual machine, which in my case is vServer 1. Lastly, I will add the name switch, followed by the name of the integration service. In my case, I will choose to enable the Guest Service Interface. In the description of this video, I will provide a complete list of the integration service names for your reference. I will now run the command, close Windows PowerShell, refresh the settings screen, and will once again select Integration Services. As you can see, the guest service is now enabled. To disable an integration service using PowerShell, you can use the Disable-VMIntegrationService commandlet, followed once again by the VM name switch and the name of the virtual machine. And finally, add the name switch, followed by the name of the integration service you wish to disable. Once the command is run, I will close Windows PowerShell and refresh my virtual machine settings. As you can see, the guest service is once again disabled. Now that we know how to enable and disable integration services, I will now move on and discuss the actual Hyper-V services. To begin with, I would like to discuss a service which is not part of the Guest Integration Services package, called the Hyper-V Virtual Machine Management Service. When Guest Integration Services are installed onto a virtual machine, this service is not included. So, what exactly is this service? The Hyper-V Virtual Machine Management Service is a service which runs on the Hyper-V host machine. When you install the Hyper-V role onto a Windows Server 2012 or Windows Server 2012 R2 server, the Hyper-V Virtual Machine Management Service is added to the server. The Hyper-V Virtual Machine Management Service allows you to manage your virtual machines in Hyper-V Manager. If this service is stopped or crashes, you will not be able to manage or administer your virtual machines in Hyper-V Manager. It is worth noting at this point that if this service is stopped, although your virtual machines will become unmanageable, they will still continue to run. To prove this, I will now change back to my Windows Server 2012 R2 Hyper-V host. If I open Server Manager, you can see in the top left corner that the Hyper-V role is installed on this server, confirming that it is, in fact, a Hyper-V host. Next, I will click Tools in the top right corner and will open the Services console. Since this server is a Hyper-V host, if I scroll down through the list of services, surely enough, you will find the Hyper-V Virtual Machine Management Service listed. To demonstrate the importance of this service, I will right-click the service and will select Stop from the drop-down list. After a short wait, the service will stop running. Now that the service has stopped, I will return to Server Manager and refresh the screen. Notice that the Hyper-V tile, amongst others, has changed to red, highlighting the fact that there is a problem with a service. If I open Hyper-V Manager, you can see that my 3 virtual machines from earlier are no longer listed. Instead, I am receiving an error message of "The Virtual Machine Management Service is not available." As long as the Hyper-V Virtual Machine Management Service remains unavailable, your virtual machines cannot be managed using the Hyper-V Management Console. I will now close Hyper-V Manager, reopen the Services console, and will restart the Hyper-V Virtual Machine Management Service. Once the service is started, I will close the Services console and will reopen Hyper-V Manager. Notice now that the virtual machines have reappeared. Furthermore, if you look at the official uptime for the virtual machines, you can see that all guest systems have been running for a relatively long period of time, proving that the virtual machines have remained up and running despite the service being stopped. Now that we have covered the Hyper-V Virtual Machine Management Service, I will now take a detailed look at the Guest Integration Services. The first service to discuss is the Hyper-V Guest Shutdown Service. The Hyper-V Guest Shutdown Service allows you to shut down your Hyper-V virtual machines from within the Hyper-V Management Console. Although seemingly unimportant, this is actually a very useful service. To demonstrate how you might use this service, consider the following example. Imagine that you have a Windows Server 2012 R2 Hyper-V host running 10 virtual machines with Guest Integration Services installed. Let's say that 6 of those virtual machines need to be taken down for maintenance. Of course, you could accomplish this by logging on to each virtual machine and shutting them down in turn. This will, however, require you to log on to 6 individual servers and perform 6 separate shutdowns. Whilst there is nothing wrong with this approach, in a highly virtualized environment, it can be rather time-consuming. This is where the Hyper-V Guest Shutdown service comes in. Using this service, you can simply log on to the Hyper-V host server, open Hyper-V Manager, and, with the click of a button, shut your virtual machines down from within the console. To show you how this works, I will change over to my Windows Server 2012 R2 server. There are several ways to shut a guest system down in Hyper-V. One method is to simply right-click on the guest system and select Shutdown from the drop-down list. Alternatively, you can double-click on the virtual machine and click the red Shutdown button at the top of the window. However, if you prefer, you can also shut the virtual machine down using Windows PowerShell. To do this, open a PowerShell prompt and run the command stop VM, followed by the name switch and the name of the virtual machine you'd like to shut down, which in my case is vServer1. Optionally, you could also add the force switch. This switch will close any applications that have been left open on the virtual machine. You will, of course, lose any unsaved data from those applications. Shortly after running the command, you can see that the virtual machine has cleanly shut down. The next service is the Hyper-V Heartbeat service. The purpose of the Hyper-V Heartbeat service is to detect when a Hyper-V virtual machine has possibly crashed or hung. To better explain how this works, imagine that you have a Windows Server 2012 R2 Hyper-V host running several virtual machines with guest integration services installed. When the virtual machines are running, the Hyper-V host will, at regular intervals, send a message to every guest system running on the host. This is called the heartbeat message. The Hyper-V Heartbeat service running on each virtual machine is expected to respond in kind to the heartbeat messages by sending a reply to the Hyper-V host. If the Hyper-V host does not receive a reply from a guest system, it will assume that that virtual machine has hung and will alert the administrator. To better understand how this works, I will once again change over to my Hyper-V host machine. To view the heartbeat status of a guest system, all you have to do is click on the virtual machine in Hyper-V Manager. At the bottom of the screen, notice that we have a heartbeat option. As you can see, this virtual machine is reporting a heartbeat status of OK, meaning that the Hyper-V host and the virtual machine are successfully sending heartbeat messages to one another. If the host and guest systems were to stop exchanging these messages, the heartbeat status will report that it has lost contact with the virtual machine. Of course, you can also check the heartbeat status of your virtual machines using Windows PowerShell. The command that I personally like to use is the Get-VMIntegrationService command, followed by the name switch and heartbeat. Lastly, I will add the VM name switch, followed by the name of the virtual machine, which in my case is vServer1. After running the command, I can see that the heartbeat service is enabled for this virtual machine, and that it is reporting a status of OK. If the heartbeat service loses contact with the Hyper-V host, this will be reported. Next, we have the Hyper-V Time Synchronization service. The Hyper-V time synchronization service is used to synchronize the clocks on your virtual machines with the clock on your Hyper-V host. This is done to ensure that the times on your Hyper-V host and virtual machines are identical. Although this may seem unimportant, in the world of computing, time synchronization is actually a very important security feature. Clever hackers are able to target networks using sophisticated attacks that involve manipulating the system time. By synchronizing the clocks on your systems, these types of attacks are harder to perform. Let me try to explain how time synchronization works. Since Hyper-V is most commonly used in an Active Directory environment, let's consider the following example. In any Active Directory network, you will have at least one domain controller. When you first set up an Active Directory domain, a total of 5 operations master roles, also called FSMO roles, are installed onto your domain controller. It is these services that provide the functionality for Active Directory. One of these operations master roles is the PDC emulator role. It is this role that is responsible for keeping the time on your computers accurate and synchronized. The domain controller hosting the PDC emulator role will, in most cases, synchronize its clock with an external time source on the internet. These external time sources are very accurate clocks, so you can rest assured that the time on your PDC emulator is reliable. From this point on, when a new member server or client computer is joined to the domain, these computers will, in turn, synchronize their time with the domain controller holding the PDC emulator role. Since all of the computers on the network are synchronizing their clocks with the same time source, you should expect the time on all of your computers to be accurate. Let's then say that you add a new Windows Server 2012 R2 member server to the domain and configure it as your Hyper-V host. This server will, just like all other member servers, synchronize its time from the PDC emulator. When you create virtual machines on the Hyper-V host, you may expect these machines to also synchronize their clocks with the PDC emulator. However, this is not the case. In consequence, this can cause the time on your virtual machines to drift from that of the Hyper-V host. At first, the time drift may appear minimal and might not even be noticeable. But after running a virtual machine for weeks or even months on end, the time drift will become more and more noticeable. This is where the Hyper-V time synchronization service comes in. When guest integration services are installed onto a virtual machine, the time synchronization service running on the guest system will synchronize the clock on the virtual machine with the clock of the Hyper-V host. Since the Hyper-V host is obtaining its time from a reliable time source, you should expect the clocks on your virtual machines to be just as accurate. The next service to discuss is the Hyper-V Volume Shadow Copy Requester. The Hyper-V Volume Shadow Copy Requester is a service which is designed to improve backups for your virtual machines. To understand how this service works, it is best to imagine what life would be like without this service. Let's imagine that you have a Windows Server 2012 R2 Hyper-V host running a virtual machine. At present, guest integration services are not installed on the virtual machine. As such, the Hyper-V Volume Shadow Copy Requester service is not running on the guest system. Now, let's imagine that you want to take a backup of this virtual machine. If you were to start the backup without the Volume Shadow Copy Requester service, the virtual machine is placed into what is referred to as the saved state. Whilst in the saved state, Hyper-V prepares the virtual machine for backup by creating what is called a snapshot. A snapshot is essentially what the virtual machine looks like at that specific point in time. However, there is one significant drawback to this approach. Whilst in the saved state, the virtual machine cannot be used. Of course, this can be very impractical, especially if the virtual machine is running some kind of business-critical application. Depending on the size of the virtual machine and the load placed on it, the snapshot could take some time to create. When the virtual machine is ready to back up, the virtual machine will once again become accessible. Understand, the virtual machine does not remain in the saved state for the duration of the backup, just the snapshot phase. This is where the Hyper-V volume shadow copy requester service comes into play. When guest integration services are installed onto the virtual machine, and the volume shadow copy requester service is running, backups of the virtual machines are handled differently. With this approach, Hyper-V will use volume snapshot services, commonly abbreviated as VSS, to back up the virtual machine. VSS, in a nutshell, allows data files and volumes to be backed up even whilst they are in use. The main benefit of this is that you are able to back up your virtual machines without any downtime or interruptions. When the Hyper-V volume shadow copy requester service is enabled, you can rest assured that backing up a virtual machine will not take it offline. One final point I would like to make is that virtual machines running Windows XP or earlier cannot use the volume shadow copy requester service. If you are planning to deploy legacy operating systems such as Windows XP as virtual machines, you should be aware that backups could temporarily make your virtual machine unavailable. I will now change over to my Hyper-V host to demonstrate how backups can affect your virtual machine. In Hyper-V Manager, I will first open the settings for one of my virtual machines. Once in Settings, I will select Integration Services. In the main pane, notice that Backup Volume Checkpoint is currently enabled for this virtual machine, meaning that if I were to back it up right now, the virtual machine will remain accessible. For demonstration purposes, I will disable the Backup Integration Service for this virtual machine and apply the changes. I will then open the virtual machine window and will log on. I am now ready to back up my virtual machine. Since I have already created a backup job on my Hyper-V host that will back up the virtual hard disk of this virtual machine, I will open Windows Server Backup. Although I am using Windows Server Backup, you can expect the same outcome if you are using a third-party backup solution. From here, I will start a manual backup of my virtual machine. If I change back to my virtual machine, notice that the virtual machine will turn off suddenly, and the virtual machine will enter the saving state. Since the volume shadow copy requester service is disabled, Hyper-V cannot create the snapshot of the virtual machine whilst it is in use. Once the snapshot is created, the virtual machine will become available again. I will now go back into Windows Server Backup and will cancel the backup. Next, I will open the settings for my virtual machine and will re-enable the Backup Integration Service. Notice what happens when I attempt to run another backup of my virtual machine. As you can see, the virtual machine does not close and remains accessible. This is because Hyper-V is now using VSS to back up the virtual machine, which allows snapshots to be taken even whilst the guest system is in use. The final guest integration service to discuss is the Hyper-V Guest Service Interface. This service was introduced in version 6.3 of Guest Integration Services. As such, it is only available to virtual machines that are running on a Windows Server 2012 R2 Hyper-V host. If you are using Windows Server 2012 as your Hyper-V host, this service will not be available to virtual machines. The Hyper-V Guest Service Interface allows you to copy files from your Hyper-V host server to a virtual machine without using a network connection. To visualize this better, consider the following scenario. Imagine that you have a Windows Server 2012 R2 Hyper-V host server running a virtual machine with guest integration services installed. The virtual machine does not have a virtual switch attached to it, which essentially means it has no network connectivity. Let's say you have a file on your Hyper-V host that you want to transfer to the guest system. In earlier releases of Hyper-V, you would either have to configure the virtual machine with network connectivity, or move the file into a virtual hard disk and then attach this virtual disk to the guest system. Although these methods do work, they do require more administrative overhead. With the Hyper-V Guest Service Interface, you are able to move files seamlessly from the Hyper-V host to the guest system. To demonstrate how this is done, I will change back to my Windows Server 2012 R2 Hyper-V host. The Hyper-V Guest Service Interface is different to the other guest integration services in that it is disabled by default. To use this service, you will have to manually enable it for every virtual machine you wish to use it on. To do this, right-click on the virtual machine and open the settings from the drop-down list. This opens the settings for the virtual machine. On the left-hand side, select Integration Services. This will show all of the guest integration services that are enabled for use on this virtual machine. By default, all services are enabled, apart from guest services, which is disabled. To enable guest services, simply tick the checkbox and click OK. The Hyper-V Guest Service Interface is now enabled on this virtual machine. If I open File Explorer on this server and open the C drive, you will see a file named test.txt. This is the file that I will transfer to my virtual machine. So, how do we copy a file from this host to our guest system? Well, we have to use a PowerShell command. If I open a PowerShell prompt on my host system, I will run the commandlet Copy-VMFile, followed by the name of the virtual machine you want to copy the file to. Next, I will add the switch source path, followed by the path to the file I want to copy, which in my case is c:/test.txt. Next, I need to add the destination path switch, and will specify the location on the virtual machine I'd like to copy the file to. To keep things simple, I will place this on the C drive of my virtual machine. And finally, I will add the file source switch. Enter host, and will run the command. Once complete, I will close Windows PowerShell, launch my virtual machine, and log in. From the desktop of my virtual machine, I will open File Explorer and will then open the C drive. In the root of the drive, you can see the test.txt file that I have just copied. This concludes this lesson on the Guest Integration Services package. I hope you have enjoyed this lesson and found it useful. In the next lesson, I will look at how to create snapshots and checkpoints of your Hyper-V virtual machine. lessons. For more Windows Server 2012 and Windows Server 2012 R2 training videos, feel free to browse our collection of videos on YouTube. And remember to show your support by liking our videos and by subscribing. Many thanks, and we'll see you on the next lesson.